graduate research was trying to understand the regulation involved in embryonic development, specifically in determining how the front of the embryo becomes different from the back of the embryo. And I studied snail development, and snails are a great example of early specification in development. So at the 4-cell stage, they have labeled and know from the 4-cell stage what every cell becomes in the animal. And the question is, how does that get set up at such an early stage? And it was previously thought that the cells inherit information that determines what they're going to be. And in my research, what I did was a lot of looking at interactions between the cells, and I actually went in and destroyed specific cells in the embryo and then looked to see how the other cells were affected by that. And I found that there was an important communication that went on early on in the development of the embryos at the 24-cell stage, which helped with the specification of the front of the embryo versus the back of it. But snails have a very different mechanism of early development than do vertebrates, for example, and humans. But a lot of the same signaling molecules are involved, and humans involve a lot of communication between cells. Spiralians and gastropods, for example, were thought to involve less communication between cells. It was thought to be more autonomous development, again, where the cells are inheriting signaling molecules or inheriting molecules that help with specification. So, yeah, so it was comparisons amongst all different organisms.